class, we have discussed the MCQs based on aldehyde and ketones, right? So today we are going to see the MCQs based on carboxylic acid. I think we have completed the uses of aldehydes and ketones. Okay. So did you solve the other questions from aldehydes and ketones? Okay, okay. So you just try to solve them. Okay, so it will be a good practice for you. Okay, so we'll start with methods of preparation of carboxylic acids. Okay, okay. So the 64th question, just see the 64th question. The reaction that does not give benzoic acid as the major product is. Okay, so these are the four reactions wherein you have to see benzoic acid. So what is the structure of benzoic acid? Benzene. Okay. COH. So this is the benzoic acid. So the reaction that does not give benzoic acid as the major product is. So they have taken here benzyl chloride. Okay. So benzyl chloride is reacted with the potassium dichromate. So what will be the reaction with potassium dichromate? Then they have taken here uh, phenyl, methyl phenyl ketone, right? So this is a ketone. One ketone is here. So they have treated with NaOCl and followed by hydrolysis. Next reaction, benzyl chloride is treated with PCC. Okay, that is pyridine chlorochromate. So this is also a oxidizing agent. Then again, next reaction, benzyl alcohol is treated with potassium dichromate. Okay, and they are subjected to hydrolysis. That is, in acidic medium, the oxidation is taking place. So you have to tell which of the reaction that does not give benzoic acid as the major product. Yes. Option C. Okay. So option C, what it is? PCC, that is pyridium. So benzyl chloride is taken. Okay, benzyl alcohol, sorry, benzyl alcohol. So in the presence of PCC. So PCC is what? It is pyridinium chlorochromate. Okay. So what type of reaction it is going on? So PCC, what it will do? So PCC is a reagent, okay, which will stop the oxidation at only aldehyde. So in other cases, okay, potassium dichromate, your sodium oxochlorate, okay, and potassium dichromate. So these are strong oxidizing agent. So directly your alcohol is converted into carboxylic acid. Okay, that is, they are converted into benzoic acid in all the other three cases. But here, instead of going for carboxylic acid, the reaction it stops at aldehydic stage. Okay, so it forms a benzyl aldehyde. Okay, therefore, it prevents further oxidation of aldehydes to ketones. So, in these other reagents, okay, other reagents, what they will do, they will directly oxidize the ketone or alcohol to carboxylic acid. But your PCC, what it will do, it will restrict the what uh, further oxidation. So directly your alcohol is converted to aldehyde. So further conversion from aldehyde to carboxylic acid is not possible. So the reaction that does not give benzoic acid as the major product is option number C. So PCC, okay, pyridium chlorochromate, it stops the oxidation at aldehydic stage. So therefore, it prevents the further oxidation of aldehydes to carboxylic acid. So this is the answer. Next question, 65th question. Which one of the following esters get hydrolyzed most easily under alkaline condition? So which is the ester which gets easily hydrolyzed under alkaline condition? Alkaline condition means basic condition. Okay, in the basic condition. Yes. So in you can see here all are what? Or are aceto group. Okay. Or are aceto group, right? Acetyl group. So all are acetyl group in this attached to the benzene ring. So all are acetyl group attached to the benzene ring. Here the type of substituents which is attached. So here also it is a COCH3. Okay, OCH3, that is methoxy group is attached. Here there is no any substituent. Here it is a chloro substituents and here is a nitro substituent, right? So what will happen? So which one of the esters will get hydrolyzed more easily? So it depends upon the type of group which is attached. Okay. Now here in this case, so whenever you have electron withdrawing groups, right? So what are the role of electron withdrawing group? So whenever electron withdrawing groups are there, what they will do? They will increase the reactivity. Okay, it will increase the reactivity towards what? It will increase the reactivity towards your nucleophilic substitution reaction. Okay, it increases the reactivity towards the nucleophilic substitution reaction. So here you can see which is the nucleophilic electrophilic substitution withdrawing group in the uh, following options. Can you tell me? It is a nitro group, right? It is a nitro group. So nitro group, it is a strong electron withdrawing group. So whenever such electron that is strong electron withdrawing groups are attached to the benzene ring, what they will do? They will increase the reactivity. Okay, they will increase the reactivity towards the nucleophilic substitution reaction. So next question, consider the following compounds. So these are the four following compounds. So you have to tell the correct decreasing order of their reactivity towards the hydrolysis is. Okay. So based upon the type of substituent attached, so you have to tell the type of reactivity. Okay. Order of reactivity towards the hydrolysis. So this is the given, it is given as 1, 2, 3, 4. You have to see the order, you have to write the correct order in decreasing order of their reactivity. Decreasing order means which will be the strongest. So whenever hydrolysis is going on, right? So whenever you have a strong electron withdrawing group, okay, that is strong electron withdrawing groups. So the reactivity towards the nucleophilic substitution will go more easily, right? So here, which is a strong oxidizing group first. So the strong oxidizing group, okay, in the following compounds is first is your nitro group, right? First is your nitro group. So nitro group is a strong oxidizing, that is a strong electron withdrawing group. So first will be 2. Okay. First will be your 2. So this compound will come first because we have to write a decreasing order from strongest. Okay, from strongest to your lowest. From strongest to lowest. So first will be your this group. Okay. Then second comes what? So next is which one? Next will be your aldehyde group. Okay, next will be your aldehyde group. So aldehyde group because of the C double bond OH. Okay, because of the carbonyl group, so it will tend to withdraw the electron towards itself. So as it has a carbonyl group, so aldehyde group it is having a carbonyl group, so it will tend to pull the electron towards itself. So next will come your fourth one. Okay, next will be your fourth one. Next is which one? Uh, in your okay, one is your CH3, another is phenyl COCl. Okay, so next is what? So next, this is what CH3. CH3 is a electron donating group. So it is a electron donating group. So your phenyl is there, right? So next will be your first one. Okay, first one, and then comes your electron donating group. That is second one. Sorry, first one. Uh, I've confused here. So this will be third one. Okay, first one, and then comes your third one. Okay, so like this. So based upon the electron withdrawing groups, you have to write from decreasing to increasing order. Okay, from decreasing order, you have to write the reactivity towards the hydrolysis. So first, whenever you have electron withdrawing group, so that will go, it will show the reactivity more strongest. So here the electron withdrawing group, which is more strongest, is your nitro group come first. Then comes your aldehyde group because of the carbonyl group, and then between phenyl group, that is a benzyl group, and it is benzyl, no? Just a second. Yes, between your benzyl, okay, benzyl chloride, that is benzyl chloride, and your this what methyl attached group. So this is a electron donating group. Okay, electron donating group. So this will come first. So one, and then comes your third. So which is your correct option? Option number C. Okay, option number C is the right answer. So option number C is the correct answer. So we'll go for the next one. Next question, 67th question. So we have taken a MgBr. Okay. So this is to be reacted with carbon dioxide. Okay, and then you have to undergo hydrolysis. Then it will undergo what? Hydrolysis. Hydrolysis. So MgBr. Okay, when you are what it is treated with carbon dioxide. So what will be the product P? They have asked. Okay, so this is a benzyl magnesium bromide, right? So it is a phenyl magnesium bromide, you can call it. So this is a organometallic compound. So this is what it is like RMGX, right? It is like RMGX. So it is a organometallic compound, right? It is a Grignard reagent. So this you are going to treat it with carbon dioxide, and further it will go hydrolysis. So what will be the product P in the following compound? So when your grignard compound is there, that is your organometallic compound is there, and you are reacting it with carbon dioxide. Yes, what will be the P? You just go to the option number A, B, C, and D. Mg, Br. So carbon dioxide. Okay, yes, B is right answer. So we'll see how it is. Okay, so this is carbon dioxide. So when you are so what will happen here? Your This will attack at this carbon. Okay, and in turn, so there will be bond movement. So how the attack will takes place? Just see here. So this will be the reaction like this. Then C. Okay, double bond O here. So this O. So to this O, what is attached? MgBr. OMgBr. So Mg will be minus. Sorry, O is minus and Mg is plus. This will further undergo hydrolysis. Okay, acid hydrolysis to give you what? So just see what will happen now. C double bond O. Okay, to this oxygen, what will happen here? Okay, here H will be added and your OH will be added here. So this will be OH plus Mg, Br and OH like this. Okay, so this is our side product. So what is your product B? What is your product B? What it is called as? This is called as benzoic acid. So it is B. Okay, you will get benzoic acid. So this is the reaction. Okay, I hope this is clear. So like this, the reaction will proceed. So organometallic compound when react with carbon dioxide. Okay, so this is the reaction. Next question, 68th question. Which of the following compounds gives benzoic acid on hydrolysis? Okay, benzoic acid when it undergoes hydrolysis. So what is benzoic acid? Benzoic acid is this. So this is benzoic acid. So they have asked which of the following. Okay, you have answered it as B. So we'll see. So the first one is chlorobenzene. Okay, chlorobenzene is what? Chlorobenzene. This is the structure of chlorobenzene. So chlorobenzene, when it undergoes hydrolysis, okay, it will not give you benzoic acid. Okay, benzoic acid upon hydrolysis. Then next is benzoyl chloride. What is benzoyl chloride? Benzoyl chloride is COCl. So benzoyl chloride, if you treat it with water, okay, what will be the reaction? It will, here what is added? COOH is added plus HCl. Okay, so this is benzoic acid. Fine. So option number B is the right answer. So whenever you take benzoic acid, okay, benzoic acid upon that is when you take benzoyl chloride and you undergo hydrolysis, it will go, you will get that benzoic acid. So we'll go for the next question. Carboxylic acids have higher boiling point than aldehyde, ketones, and even alcohols of comparable molecular mass. It is due to their A. Formation of intermolecular hydrogen bonding. B. Formation of carboxylate ion. C. More extensive association of carboxylic acid via van der Waals forces of attraction. And D. Formation of intermolecular hydrogen bonding. So this was a question asked in NEET 2018. So why the carboxylic acids are having higher boiling point than aldehyde ketones and even alcohols with comparable molecular masses? This we have seen in theory part. Option D. Okay. So just a second. So carboxylic acid. So carboxylic acid, they have higher boiling point than aldehydes. What is aldehyde? So I can take a aldehyde. I'll take it as R, right? Then ketone and even alcohols. So this is more. Okay, in case of carboxylic acid, the boiling point is more because of the formation of intermolecular hydrogen bonding. What do you mean by intermolecular hydrogen bonding? So whenever this carboxylic acid group, when it comes with other molecules, okay, when it comes in association with other molecules, so it has a tendency to form intermolecular hydrogen bonding. What do you mean by intermolecular hydrogen bonding? Between the two different molecules. So the hydrogen bonding will be between the two different molecules. Okay. So the option number D is the right answer. So uh, because of the formation of intra means what? Intra means within the molecule. So within the molecule, it is not possible. Okay. Intramolecular hydrogen bonding means within the molecule. So this is also wrong. Formation of carboxylic ion. Ion means CO minus ion. So no, not this reason also. Then next is what? More extensive attraction of association of carboxylic acid by a van der Waals forces of attraction. No, not this also. Okay. So it will be option number D. So it is due to formation of because in carboxylic group you can see there is a OH. Okay, more electronegative. Okay, more electronegative atom, that is oxygen, is present. So this oxygen atom, which is combined with hydrogen, okay, it has a tendency to form hydrogen bonding with other molecules. Okay, so we'll go for the next question. So next is chemical reactions. So we'll see the chemical reactions. So the first question, so they have given two lists. Okay, list one and list two. So what you have to do? So list one is the reactions they are given, and list two there are some names of the named reactions. Okay, common named reactions. So you have to match. So you have to choose the correct answer from the options which is given below. So just see and tell me which is the correct answer. So benzene, when you are reacting it is with carbon monoxide in the presence of HCl, that is hydrochloric acid, in the presence of anhydrous AlCl3 or CuCl. Okay, what reaction it is? What is the name of the reaction? Option A. So benzene. Okay, what is the reaction? What you get with benzene when you react it with carbon monoxide and hydrochloric acid in the presence of anhydrous aluminum, that is anhydrous aluminum chloride? What it will give you? What is the reaction? So when you react your benzene, okay, in the presence of carbon monoxide and HCl, in the presence of anhydrous AlCl3 or cuprous chloride, you get benzaldehyde. What you get? Benzaldehyde. Okay, so this same reaction is called as Gattermann-Koch reaction. So this name reaction is called as what? It is called as Gattermann-Koch reaction. So it is so Gattermann-Koch reaction. So option number, okay, A will match with 2. Then next reaction, RC double bond O CH3, okay, plus NaOX. Yes, what is this? What will be the product? Tell me what will be the product. What will be the product? So when you are reacting your aldehyde or a ketones, okay, at least one methyl group should be present in that. So at least your one methyl group is present. Fine. So whenever such groups are present, that is one methyl group is attached to a carbonyl group, it is called as what? It is called as methine ketones. Okay. So what we are doing? We are doing oxidation. That is with the help of sodium hypohalite. So this is sodium hypohalate. Okay, this is sodium hypohalite. So it is sodium hypohalite. So when you react it with sodium hypohalite, it forms a salt. Okay, it forms a sodium salt. So corresponding sodium salt is produced of this carboxylic acid, and which is containing one carbon less than that of the parent chain. Okay. So this reaction in which your methyl group is converted into CHX3. So just see the product. So one of the product will be your salt of ester. Okay, it will be salt of carboxylic acid. So it is a sodium salt of carboxylic acid. Okay, and another, so what you get, this CH3. Okay, this CH3 will break and it will form CH3X, CHX3. So you get CHX3 plus. Okay, so this is a halo form. This is a halo form. So what you get is halo form. Okay, it is a halo form. So what we are doing here, we have taken a methyl ketone and reacted with sodium hypohalite. So what you get a sodium salt of carboxylic acid and halo form. So this is a halo form reaction. What it is? It is a halo form reaction. So this is a halo form. Now the next one, R CH2OH plus R dash COOOH in the presence of concentrated acid. Okay, H2SO4 they have taken. Yes, what is this reaction? Whenever alcohol, okay, suppose so this is alcohol and this is a carboxylic acid. So alcohol and carboxylic acid, when they react in the presence of acid, what they form? They form ester. What they form? They form a ester. What they form? They form a ester. So what is ester? Ester, what type of linkage is there in ester? RO, R dash. Sorry, R, C double bond. Ester will be like this. C double bond O, R dash. Okay, like this. This is the ester bond, ester linkage. Okay. So what will be the product here? Can you tell me what will be the product? So this is a esterification reaction. This is a esterification reaction. Try to tell the product of esterification which is found here. So here, how to write this reaction? I'll show you once more. Okay. Now suppose take red color only. So if I take here uh, HO, what was the reaction? HO C double bond O R dash, right? So if I rub this, if I erase here, so what will be our byproduct? It will be water. So if I take H2O, okay, if I take H2O like this, so what will be the byproduct? Just see here, right here now. So one will be H2O, another will be R C double bond O CH2 R, right? So this is the product which is formed here, right? So water and one is ester. So one more is ester. So this is the esterification reaction. So esters are very fruit smelling. Okay, they have a very good smell. So this is the C option. Then last one, what is the reaction? Last reaction. Last reaction. So I'll erase all this. So last reaction, you have R CH2 C double bond OH. So again, acid, carboxylic acid. So carboxylic acid is taken in the presence of X2. Okay, and red phosphorus, and further it is undergoing hydrolysis. Okay, it is undergoing hydrolysis. So what is the reaction? So this is a Hell-Vollard Zelinsky reaction. Okay, Hell-Vollard Zelensky reaction. So option number A is the right answer. So like this. So like this, you have to see the at least two name reaction. Okay, if you come to know at least two name reaction, then you can guess the options. Okay, so this will be a answer. So A is the answer. So next question. The major product of the following reaction is. So which is the major product among the following reaction? They have taken COH COH plus ammonia in the presence of when you are doing a strong heating. Okay, so what will be the product? So when you take, yes, what is the answer? So the name, what will be the name? It will be benzene 1,2 dicarboxylic acid, or the other name is phthalic acid. Okay, it is phthalic acid. So phthalic acid when you treat it with ammonia. Okay, phthalic acid when you treat it with ammonia. Phthalic acid when you treat it with ammonia. So what it will form? First it will form a phthalimide. Okay, first it will form a phthalimide. So if you heat it with the, okay, first it will form a phthalimide. So C double bond to NH2. Okay, so this is phthalimide. Then further again you have to what you have to do further, again you have to heat it. Okay, still it is to be heated. So this reaction, it is continuing with a strong heating. So what will happen? This NH3 group will be released. Okay, and you get a thalamide. So this is so how you get it, C double bond O N H, C double bond O NH. Okay. So our option, which is the correct answer, C. So C is the correct answer. So phthalic acid, when you do strong heating with a, so this is also a base. Okay, it is a alkali, strong alkali, that is NH3. So you get a thalamide. Okay. Further again heating, there will be loss of NH3, and you get a thalamide. Okay. So this is the reaction. I hope this is clear. So we'll go for the next. These are almost the same questions. We'll go for the next page. Okay. So next is derivatives of carboxylic acid. Okay, the product formed in the following chemical reaction is. So this is a chemical reaction given. Okay, so you have to tell what is the product formed here. So CH2, C double bond O, OCH3. This is CH3 in the presence of sodium borate and ethanol. Okay, so you have to tell which is the product formed here. So which is the product formed here? So here, what will be the products here? So you are doing what? Sodium borate in the presence of. So here you have a double bond, right? Okay, here you have a double bond. So now what will happen? So this double bond will be intact. Now here what you get is CH2. Okay, CH2. So this will remain as it is. So here the sodium borate which you have used, okay, the sodium borate which you have used, it is a less powerful reducing agent. So sodium borate which we have used here, it is less powerful reducing agent than your lithium aluminum hydride. So you know that lithium aluminum hydride, it is a strong reducing agent and it is very costly. Okay, it is very costly. So this is a strong reducing agent. So if you use this agent, then some reaction can be possible. Okay, it can be reduced to, if you use this lithium aluminum hydride, then your ester can be reduced to aldehyde ketones. Okay, and acid chlorides to alcohols. So it can be converted. So whenever you have lithium aluminum hydride, so sodium borate, it is very less powerful reducing agent than your lithium aluminum hydride. So it is only powerful. Okay, sodium borate will be only powerful whenever you have to reduce any aldehyde, okay, or your ketone or your ketone, okay, or acid chlorides to alcohols. To alcohol, that time only it acts as a good or strong reducing agent. But or in other cases, like whenever you have esters, okay, or amides, then you have acids, okay, and nitriles. So that time they do not they are not so powerful. Okay, so because of that the reaction will be same as it is, so there won't be any change in the reaction. Next question. Match the following compounds. Okay, list one and with list two and select the suitable option using the codes given below. Benzaldehyde, phthalic anhydride, phenyl benzoate, d-phenyl methyl salicylate. Then in list two, phenolphthalein, benzoin condensation. Three, uh, oil of wintergreen, and fourth, fries rearranged. Okay, so 93rd, the option is here. So whenever benzaldehyde is there, it undergoes benzoic condensation. Then phthalic anhydride, okay, it is used in the formation of phenolphthalein. Then you just see A is second answer and B is first answer. So just see. Then methyl salicylate. Okay, methyl salicylate. Methyl salicylate is used for the as a oil of wintergreen. Okay, so it will be option number D. Option number D. Okay, so last question you see 98 question sodium formate. Okay, sodium formate is what? This is your formic acid. Sodium formate means your H will be converted to, so this is sodium formate. So sodium formate on heating. So when it undergoes heating, so what it forms? Oxalic acid and H2, sodium oxalic and H2, carbon dioxide and NaOH and sodium oxalate. So it forms what? Sodium oxalate plus H2. Okay, it forms sodium oxalate with H2. Okay, so this is the reaction sodium oxalate and H2. Okay, so these were some of the questions. Okay, so these were some of the questions which we have solved related to carboxylic acid. So by this we have completed the chapter aldehyde, ketones, and carboxylic acid. So we have completed the synopsis part. Then in the previous class we have completed the questions on aldehydes and ketones, and today we have seen carboxylic acids. Okay, so is it clear whatever the questions are being dealt now? Okay.